So here is question number 85, right? We have the point 2 comma 7 pi over 6. This is the polar point that we're looking at. We want to convert this polar point into a rectangular coordinate point, right? So we are really saying that r comma theta needs to be converted and it needs to look like x comma y. So if we think about this, we know that r comma theta, well, 2 must be the radius that we're talking about, and our angle theta must be 7 pi over 6 in terms of radians, right? We want to convert that into x comma y as the coordinate point. So if we're looking at this, we should understand obviously that the two main formulas here that would apply are x is equal to r cosine theta, and then y is equal to r times sine theta, right? And so here, when we're converting, we know that x must equal r times cosine theta. Well, that means that this is really just 2 times cosine of 7 pi over 6, comma, 2 times sine of 7 pi over 6, right? That's what the x comma y is representing. So if we take cosine of 7 pi over 6, right, we know that's in the third quadrant. We know that the reference angle is pi over 6. You know cosine of pi over 6 is root 3 over 2. However, this is in the it's in the third quadrant, right? Therefore this value must be negative. So when we evaluate this, right, we know that this is really saying 2 times the negative root 3 divided by 2, negative root 3 divided by 2, comma, well, sine of 7 pi over 6, sine of pi over 6 is 1/2, third quadrant also has to be negative, right? So we have negative 1/2 here, so 2 times negative 1/2, that's just negative 1. And if we further simplify this, we should see that this is negative root 3, comma, negative 1, comma, negative 1, right? So we have this, and this makes sense because when you have negative, comma, negative, right, when both your x and your y are negative, well, that indicates that this point over here must be in quadrant 3, and that makes sense because really what this point over here, this x comma y, is really corresponding to this polar form, 2 comma 7 pi over 6. You know 7 pi over 6 is in the third quadrant, so it's specifically saying that, oh, somewhere in the unit circle, or not a unit circle, right, it could be any type of circle with a certain radius, right, in this case with a radius of 2. Well, so you're going 7 pi over 6 with a radius of 2, right? So obviously, you know, it has to be in the third quadrant, and so if it is in the third quadrant, your points, your x comma y, are obviously need to be negative as well. Your x in the third quadrant is negative as well as your y. So you can obviously check your work knowing wherever the angle should be, right? If this is, for instance, 5 pi over 6, if it's in quadrant 2, then you should understand that if it's in quadrant 2, well, your x value may possibly be negative, right? Or it is negative, obviously, and then your y value is positive. So you would have something like, I don't know, negative root 3, comma, positive 1. So that's question number 85. So now we have another question, 86. So 86 here states we have 2 root 2, and we have comma negative pi over 3, right? Again, this is a polar, right? R comma theta. We want to convert this into the rectangular x comma y. Let's look at these two equations. We use the same concept here. We know that x is equal to r times cosine theta. Well, that's 2 root 2 times cosine of negative pi over 3, comma, 2 root 2 times sine of negative pi over 3. Just for clarity purposes, if you know these two equations or these two rules, it will help you. Cosine of negative x is always equal to cosine of x, right? Because negative x is really means that you're going counterclockwise in this direction, right? And obviously quadrants 1 and 4, in both of those quadrants, cosine is positive, right? And then if you have sine of negative x, well, that is equal to negative sine of x, right? In quadrant 4, sine of x is negative. So if you know these two equations, that's gonna help you here. So when we're talking about cosine of negative pi over 3, well, that's just equal to cosine of pi over 3, right? And cosine of pi over 3 is 1/2. 1/2 times 2 root 2, well, that's root 2. So we know this is root 2. And then we have this. Now we're looking at this. So sine of negative pi over 3 is equal to negative sine of pi over 3. Well, you know sine of pi over 3 is root 3 over 2, and you need to have that negative. So we are talking about negative root 3 divided by 2, right? And so this should be our answer here, right? When we're looking at this, so we know that, so we had this. Actually, I think I messed up here, because we have sine of negative pi over 3 being negative root 3 over 2. Now we have to multiply this by 2 times root 2. I forgot about the 2 times root 2, right? And so if we multiply, obviously the 2's go away, and we're left with negative root 3 times root 2, which is negative root 6. So we have negative root 6 over here, right? So we have root 2, comma, negative root 6. That is our answer. Looking at this, we know that this is somewhere in quadrant 4, right? Because obviously the x is positive and the y is negative. So this is in quadrant 4. Now, is this angle also in quadrant 4? And if you're not so much sure with radians, you can obviously convert this into degrees and find out. So, well, you should know that at least that pi over 3, right? I can just do that still. So if you want to convert this into degrees, right? Obviously the pi's go away, 160, so you're left with negative 60 degrees. We already know that pi over 3 is 60 degrees. Well, negative pi over 3 is negative 60 degrees. Now, if you're going 60 degrees this direction, right? This direction, clockwise, right? Then you're going to land somewhere here. But now, if you had been more than 90 degrees, you would have it in quadrant 3. More than 180 degrees, somewhere here in quadrant 2. However, 60 degrees will still put you somewhere in quadrant 4. So this point over here is valid. So your answer to question number 86 is root 2 comma negative root 6. So thanks for watching.